Hello everyone. In the previous session we have discussed the concept of random variables and types of random variables and the probability distribution of a continuous random variable. So as I already said, we have two types of random variable. First one is discrete and continuous random variable. Anyhow, we have already studied the probability distribution of discrete random variable. So in this session, let me explain probability distribution of continuous random variable. Probability distribution of continuous random variable. Continuous random variable. We also call this as, probability distribution of continuous random variable is also known as density function. So one and the same. We can also say this as density function. So both are same. Clear? Now, what actually this density function is? Suppose if you have a non-discrete random variable x, as I already told you the meaning of a discrete variable, random variable. So if this is a non-discrete random variable, discrete in the sense which contains only what we say positive integer values. Continuous in the sense it should contain along with the decimal, right? So if this is not a discrete in the sense it is continuous, that's all. So if it is a non-discrete random variable, then we say this is a continuous if its distribution function f of x is represented by p of x. Fine, this distribution function f of x will be represented by some function p of x such that it should satisfy two conditions. So as I already said, in discrete random distribution, when do we say it is discrete random distribution? It should satisfy two conditions. First condition is that probability of all the random variables should be greater than or equal to 0, and second condition is that sum of all the probability of random variables should be equal to 1. So similarly, we say distribution is continuous random distribution. Continuous random distribution only when it satisfies two conditions. First condition is this function should be greater than or equal to 0, and second condition is integral over the sign minus infinity to plus infinity f of x into dx should be equal to 1. Don't get panic, you don't have much integration in this chapter, only you have simple integration. It is very easy chapter if you concentrate well. So I'm just repeating once again, discrete probability distribution in the sense probability of xi should be greater than or equal to 0 and sum of all the probability is equal to 1. Anyhow, we have already done problems on it. Now in this session, let me explain the continuous probability distribution. So we can also say continuous random distribution as density function, one and the same. So a given function f of x should satisfy these two conditions, then only we can say it is a continuous random distribution. Fine. Meaning is first condition is it is similar to the discrete distribution, that is f of x should be greater than or equal to 0, and the second one is, and when you are going to take integral of the function, that should be equal to 1. Fine. So f of x is called as density function or a continuous probability distribution of a random variable. Density function. Density function is same as probability distribution of a continuous random variable. This is for discrete random variable, this is for continuous random variable. And one more note point you have to remember, that suppose if a set A is given in such a way that A less than x less than b, meaning of this statement is the value of x will be in between A and b. Fine. Then we can write probability of this set A as integral from these limit a b, where a is a lower limit and b will be upper limit, a to b f of x into dx. Fine. Or else we can write the same statement as probability of a less than x less than b, that is probability of this value, will be equal to integral from a to b f of x into dx. So one and the same. Remember, when you're going to take probability of this set, we can represent either in this notation or in this notation. So this is what the probability distribution of a continuous random variable. So let me solve a few problems based on it. So here is the first question. We have to find the constancy such that the given function f of x, this is something like a step function, meaning is this f of x will be equal to cx square when the value of x will be in between 0 and 3. For our remaining values, the value of f of x will be 0. Is a density function, and compute probability of 1 less than x less than 2. So as I already told you, whenever we need to calculate, whenever you are dealing with the density function, it should satisfy first two conditions, right? First condition is that f of x should be greater than or equal to 0, and second condition is that integral from minus infinity to plus infinity f of x into dx value should be equal to 1. So that should satisfy these two conditions. That is density function. Every density function f of x should satisfy these two conditions, right? Now first condition is f of x should be greater than equal to 0, meaning is the given function will be greater than or equal to 0, since second condition is obvious. Why? Because it is equal to 0. Fine. For the first function, that is for the first value, it is cx square, right? F of x is given as cx square, so this will be greater than or equal to 0 only when c is greater than or equal to 0, right? Suppose if c is negative, that is if c is less than 0, then function will become less than 0, right? So in order to satisfy this function this condition, f of x is equal to cx square should be positive, that is c value should be greater than equal to 0, then only this value will be greater than equal to 0. Whenever this is true, only when x lies between 0 and 3. Now let me find the second condition, that is we have integral from second condition is minus infinity to plus infinity, f of x into dx value should be equal to 1. Right? Now here the function value f of x is c into x square. Now whenever the value function is cx square, when the value of x is between 0 and 3. So as I already told you, when such kind is given, this has to be taken as lower limit and this has to be taken as upper limit. So lower limit is 0, upper limit is 3. Fine. C into x square into dx is equal to 1. So as per the properties of integration, c into function f of x, whenever you have such kind of function, you can take c outside, thereby I can write c into f of x, right? Similarly, I can take this as c, I'll just take outside, so that you will get 0 to 3 x square into dx, which is equal to 1. Fine. So after integration, as I already told you, integration of x power of n is x power of n plus 1 divided by n plus 1. These are the standard formula. Hope so you have already learned it in the second PU. So x square integration is c, I'll just keep as it is. X square integration is x cube by 3. Again limits, these are definite integral, we have limits here, so 0 to 3, which is equal to 1. Here we need to find the value of c, that is why I'm writing this. Why? Because it is given that in a problem itself it is clearly mentioned this function f of x is a density function. So if it is density function, it should satisfy two conditions. First condition is obvious. Why? Because for the second value it is satisfying. For the first value of a function, this will be f of x will be greater than 0 only when if c is greater than 0. If c is negative, this function is also negative, so that is the reason c should be greater than or equal to 0. So I am using the second condition in order to find the value of c. Why? Because we need to find the constant c. So as it is a density function, it should satisfy this condition. So replace f of x with cx square, where x ranging from 0 to 3. So I have changed the limit from 0 to 3. Now as per the property of integration, I can take c outside, thereby I can write x square into dx. Now integration of x square by using the formula x power of n plus 1 by n plus 1, you will get x cube by 3. Now let me substitute the limit. So as I already as you might have familiar with this, while substituting the limit, you have to first substitute upper limit. Here upper limit is 3, so you will get 3 cube by 3 minus lower limit is 0, 0 cube by 3, which is equal to 1. Anyhow, 3 cube 1 3, with this 3 get cancelled, so you will get 3 square here. 3 square is 9, minus 0 by anything is 0, which is equal to 1. So c into 9 is equal to 1. So on simplification, you will get c is equal to 1 by 9. So this is what the value of c we have already obtained. Clear? Next is we have to find the probability of here you have two questions. First one is we have to find the c, we already done it. Next is we have to find probability of 1 less than x less than 2. I'll just do here. So to find probability of 1 less than x less than 2, see it is very simple. Anyhow I have already obtained the value of c. You just substitute in a function that is in the standard form. What it is, integral from minus infinity to second condition, you have to use f of x into dx value will be equal to 1, right? So you have to simplify. See here, whenever they ask you to find c value, you have to take LHS and RHS. Since you need to find the probability of x between 1 and 2, so you just change the limits from 1 to 2. Lower limit is 1, upper limit is 2. Now f of x is, what is the value of f of x given in the problem? It is cx square. So what is the value of c? 1 by 9. So you need to substitute. I'll just do one more step. C into f of x into dx. So I can write this as integral from 1 to 2. C is 1 by 9. So anyhow it is constant, I can take outside of the integration. 1 by 9 into x square into dx. Clear? I'll just repeat once again. See here, to find the value of c, you need to use the second condition as it is, so that LHS and RHS equating, you will get c value. Next we need to find probability of x in between 1 and 2. So in order to find it, you have to consider only LHS part, that is integration of the given function. Here given function is c into x square. C value is 1 by 9, so I have taken it outside. F of x is x square. Now we need to integrate between the limits 1 and 2. So integration of x square is x cube by 3. Upper limit is 2 and lower limit is 1 into 1 by 9 is as it is. So I'll just simplify here. 1 by 9 into 1 by 3 is also outside. I'm sorry, it is constant, so let me take outside. So we will get x cube from 1 to 2. So let me let's substitute the limit. 2 cube, upper limit is 2 cube minus lower limit is 1 cube. So on simplification, you will get, I'll just keep 9 into 3 as it is. 2 cube is 8 minus 1 cube is 1. Fine. So 8 minus 1 is 7. 7 divided by 9 3 is 27. So this is the required solution. Hope so it is clear. Right? So that is what we need to calculate is probability of 1 less than x less than 2 is 7 by, I'll just write here, probability of 1 less than x less than 2 is 7 by 27. So as usual, density function notes I'll send you. After that, put the heading problems and copy down this problem and take your running notes of the same. Fine. Let me solve one more problem. So here is the second problem. A random variable x as density function f of x is equal to c divided by x square plus 1. It is c divided by x square plus 1. Where x ranging from minus infinity to plus infinity, find the value of c. Same problem, so we have to find the value of c and probability of 1 by root 3. X is in between 1 by root 3 and 1. So as I already told you, should satisfy two conditions, right? First one is f of x value should be greater than or equal to 0, and second condition is integral from minus infinity to plus infinity, f of x into dx should be equal to 1. We should use second condition in order to find the value of c, right? So let me find the solution. Anyhow, it is positive only, right? Why? Because it is given that c divided by x square plus 1, it will be positive. I'll just write here f of x will, first let me write the given data. Given function is f of x is equal to c divided by x square plus 1, where x ranging from minus infinity to plus infinity. It is given in the problem itself, so I have copied the same. Fine. So first condition is f of x should be greater than or equal to 0, right? So this will be true only when c greater than 0, greater than or equal to 0. Right? So you just write this statement. First condition is obvious. So if this is positive, f of x is also positive. Next we have to use the second condition to find the value of c. So let me use the second condition. Minus infinity to plus infinity, f of x into dx should be equal to 1. Now what is the value of f of x here? It is c divided by x square plus 1 into dx, which is equal to 1. So I'll just simplify here. C is constant, so I can take it outside. You will get minus infinity to plus infinity, 1 divided by, I write, since x square plus 1 is same as 1 plus x square, so let me write it as 1 plus x square into dx is equal to 1. Now as you already know that integration of 1 divided by 1 plus x square is tan inverse of x. You just remember this formula. It is tan inverse of x. So I can write this as tan inverse of x integral from minus infinity to plus infinity. Since here the x value is not clearly mentioned, it is given only minus infinity to plus infinity, so you have to take the same limits, that is minus infinity plus infinity only. You cannot change here. To find the c, you have to write the same limits whatever the given data in the problem. Next, after finding the value of c, you can use these limits to find the probability. Now let me substitute the limit. C as it is, upper limit is tan inverse of infinity minus lower limit is tan inverse of, in place of x we have to put minus infinity. So let me simplify. C into, what is the value of tan inverse of infinity? You have to write tan in terms of infinity in terms of tan. Infinity can be written as tan pi by 2. So I have given you a list in first sem as well. So if not, if you want, you have to memorize this. If you want, I'll just write here 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. So let me write separately. So I'll just write here 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. So we can say 0, pi by 6, pi by 4, pi by 3, pi by 2. You have to remember this. So when you're going to write sin 0 will be 0. It is 1 by 2, 1 by root 2, root 3 by 2, 1. So cos will be reverse. 1 root 3 by 2, 1 by root 2, 1 by 2 and 0. Now let me write tan 0, 1 by root 3, 1, root 3, 1 by 0 is infinity. So tan infinity is pi by 2. I'm sorry, tan 90 is pi by 2. That is tan pi by 2 is infinity. I can write infinity as tan pi by 2 minus tan inverse of minus infinity is none other than minus pi by 2, which is equal to 1. So I'll just write here C as tan inverse and tan get cancelled. You will get pi by 2 here, plus tan minus of minus will become plus here. Tan inverse get cancelled with tan pi by 2 it is. I'm sorry, minus tan pi by 2 it is. So minus of minus will become plus. Make sure that this is minus tan pi by 2. Fine. So minus of minus will become plus. So tan inverse and tan get cancelled. You will get pi by 2 is equal to 1. Now let me take LCM. You will get LCM for 2 and 2 is 2. So in the numerator also you will get 2 pi, which is equal to 1. 2 get cancelled. So C is equal to 1 divided by pi. So we have calculated C value. Remember, to find the C value you have to consider the second condition. Fine. Next we need to find probability of 1 by root 3 less than x less than 1. So let me solve here. The probability of 1 by root 3 less than x less than 1 will be equal to, as I already told you, this limit we have to consider for LHS part. So LHS is 1 by root 3, lower limit is 1 by root 3, upper limit is 1. F of x is c into x square plus 1 into dx. Fine, you just take this limit and integrate over a given function c divided by x square plus 1 into dx. Clear? Again c is constant, take it outside. So what you're going to get, integral from 1 by root 3 to 1 divided by 1 plus x square. I can write x square plus 1 as 1 plus x square into dx. Right? So c, we have already calculated the value of c. So let me substitute. C is equal to 1 by pi. Now integration of 1 by 1 plus x square is tan inverse of x. Limits from 1 by root 3 to 1. Clear? Now let me substitute the limits. I'll just simplify here. So when you substitute the limits, you will get probability of 1 by root 3 less than x less than 1. Probability of 1 by root 3 less than x less than 1 will be equal to 1 by root pi as it is. Fine. So pi. 1 by pi as it is. Now upper limit is tan inverse of 1 minus lower limit is tan inverse of 1 by root 3. Clear? Now I'll just write LHS as it is. 1 by root 3 less than x less than 1 will be equal to 1 by pi into tan inverse of 1. We have to write 1 in terms of tan. Just now I have written here. So tan 1 is none other than tan pi by 4. I'll just write it as tan pi by 4 minus tan inverse of 1 by root 3 is tan pi by 6. Right? So tan pi by 6. So let me simplify 1 by pi as it is. Tan inverse and tan get cancelled. You will get pi by 4 here. Minus tan inverse and tan get cancelled. You will get pi by 6 here. Clear? So let me simplify this. 1 by pi into LCM for 4 and 6. You just simplify if you want. I'll show you here. See here, 2 2s are 4, 2 3s are again 2 1s are 3s are 3 as it is. Again 2 2s are 4, 4 3s are 12. So 12 is an LCM. So when you take 4 12, you will get 3 pi here minus 6 2s. So you will get 2 pi here. 3 minus 2 is pi by 12 into 1 by pi. So here pi get cancelled. So the answer is 1 by 12. Therefore, probability of 1 by root 3 less than x less than 1 is equal to 1 by 12. Hope so it is clear. Right? I'll just revise once again. See, whenever they ask you to find C value, you have to use the second condition, both LHS and RHS. After that, to find the required probability distribution, you have to take only LHS part, but replace these limits with these values. That is what I have done. After rest of the things, you have to follow the same procedure. In the sense, you have to remember short formulas, integration formulas, like 1 by 1 plus x square and x power of n. Fine? Hope so it is clear. Let me solve one more problem. So here is the next problem. Here we constant instead of c, they have given it as k. This is x. This is k. So we need to find the constant x. A continuous random variable has a distribution function. This is given function. So this will be applicable only when x lies between 1 and 3. Otherwise it is 0. So we need to find the value of k and the probability density function of f of x. Fine. So let me evaluate. First let me write down the given function. Anyhow we should satisfy two conditions, right? You just write down the condition. First condition is f of x should be greater than or equal to 0. Right? Obvious, it is always greater than or equal to 0. Why? Because 4k into x minus 1 whole cube. So this will be true only when k will be greater than or equal to 0. So you just write the first condition. Second condition is that minus infinity to plus infinity, f of x into dx should be equal to 1. As usual, second condition. So we have to write the function here. F of x is 4k into x minus 1 whole cube. Here the limits is from 1 to 3. I am writing it directly. See here limits is from 1 to 3. Why? Because it is given x lies between 1 and 3. So that is why I have taken it as 1 to 3. X minus 1 whole cube into dx is equal to 1. Now 4k is constant, you can take outside. So what you left with is 1 to 3. Integration from 1 to 3 x minus 1 whole cube dx is equal to 1. Now let me integrate this. So whenever you have, remember integration of x power of n into dx will be x power of n plus 1 divided by n plus 1. Similarly, here it is of the form x power of n. So I can write this as x minus 1 power of n plus 1 in the sense 3 plus 1. 4 divided by 4. Integration limits is from 1 to 3, which is equal to 1. Now 4 get cancelled, anyhow it is constant. So you will get k into x minus 1 power of 4 limits from 1 to 3, which is equal to 1. Now let me substitute the limits. Upper limit is 3, so you will get 3 minus 1 power of 4 minus lower limit is 1. 1 minus 1 power of 4, which is equal to 1. Now 3 minus 1 power of 4 is 3 minus 1 is 2. 2 power of 4 you have to calculate. So let me write one more step. K into 2 power of 4 minus 1 is 0, which is equal to 1. Now 2 power of 4 is 16. So k into 16 is equal to 1. Fine. So k value will be 1 divided by 16. So I have obtained the value of k. Clear? Further, we need to calculate the density function. So whenever they ask you to find the density function, it is very simple. First you take the function f of x. What is the given function here? I'll just write here. So given function f of x is 4k into x minus 1 whole cube. Fine. So to find the density function, you just substitute the value of k. So f of x is equal to 4 into 1 by 16 into x minus 1 whole cube. So 4 1s are 4 4s are. So you will get f of x as x minus 1 whole cube divided by 4. So this is the required density function. That's all. Clear? Density function should be independent of constant. Since in the given function we have a constant, anyhow we have already calculated the constant here. So this will be the required density function. So in the exam, if they ask you to find the density function, first you have to find the constant value by using the continuous random variable continuous random variable conditions. That is, first condition is f of x greater than or equal to 0, and second condition is integral from minus infinity to plus infinity f of x into dx is equal to 1. Fine. Hope so it is clear. Now let me solve one more problem. So here is a problem. Fourth one. If f of x is equal to k into 2x plus 3, if x lies between 0 and 2 is the density function, and it takes the value 0 otherwise. Fine. Of a continuous random variable x, here we need to find only k. So here only k value is asked. You have to solve only for k. Now let me solve this. As usual, first condition is f of x should be greater than or equal to 0. Right. So f of x should be greater than or equal to 0. In the sense, what is the given function here? Function is k into 2x plus 3. Right. Whenever 0 less than x less than 2. So this will be obvious when k is greater than or equal to 0. So if k is positive, f of x will be positive. Fine. So I have written the function. Next condition is integral from minus infinity to plus infinity f of x should be equal to 1. So here the limits are from 0 to 2. F of x is none other than k into 2x plus 3 into dx is equal to 1. Anyhow k is constant. Let me take it outside. So you will get 0 to 2. 2x plus 3 into dx is equal to 1. I'll split it. I'll just split the integration. 0 to 2. Anyhow 2 is constant. You can take it outside. So x into dx plus 3 is constant. You can take it outside. So we'll get 0 to 2 dx, which is equal to 1. Now let me evaluate. So integration of x is x square by 2. Limits are from 0 to 2. Fine. Plus 3 into integration of dx is x. Remember, integration of dx is x. Clear? So integration of dx is x. Limits are from again 0 to 2, which is equal to 1. Now 2 get cancelled. So you will get k into x square. In the sense, upper limit is 2 square minus lower limit is 0 square. Plus 3 into upper limit is 2 minus 0 lower limit is 0. Fine. Now k into 2 square value is 4. Plus 3 into 2 minus 0 is 2. Which is equal to 1. Now 4k plus 3 2s are 6, which is equal to 1. So I'm sorry, k is multiplied for both the terms, right? So let me multiply k inside. You will get, see here I have put the bracket here. So k should be multiplied for this term as well as this term. So 6k plus 4k will be 10k, which is equal to 1. Therefore k is equal to 1 divided by 10. So here they have asked you to find only the value of k. So stop here. Stop up to here. Suppose if they asked you to find the density function, you just replace k value with the 1 by 10 in the given function. So whatever I have done, hope so it is clear. So this completes random variable, continuous random distribution, continuous probability distribution. So in the next session I will be starting with the mathematical expectations. Hope so it is clear. Further, if you have any queries, you can free to ask me. Thank you.